I will.
Hello. Hi, everyone, and welcome to this meetup. So today is Women's Day, International Women's Day. And so we're very happy to be with you today. And I'd like also to welcome the team, to introduce the team PyLadies Paris and PyLadies Munich. So Laisa, would you like to say a little hello for PyLadies
Hello,
Munich?
everyone.
Hello. I couldn't hear you, but
Hello,
maybe I don't know if
everyone.
Maria
Can you
heard
hear
you.
me
Yeah.
now?
Okay. Yes. Hey. And Maria is with me. Maria is also one of the organizers of PyLadies Paris. Hi, Maria. Hello. And we're very happy to be with you today and to welcome two great speakers. We have Tiffany and Ellie. I'm just gonna show them on screen in 1 second. So Tiffany, hey. And Ellie, yeah, hey Ellie. Welcome. We're gonna go ahead with the rest of the introduction. And up. So yes, we are PyLadies Paris and Munich, and sometimes we collaborate for great events such as the International Women's Day. And you can find us on Slack. So we have a big Slack group with all the PyLadies groups all over the world. And in these Slack groups, we have a City Paris channel and a City Munich channel where we can come and chat with us, ask us some questions, suggest some next events, say if you enjoy joining the events, etc. And we also have a Twitter account, so PyLadies Paris and PyLadies Munich. On top of this, I'd like to say that we are live on YouTube, and we are very happy to get some news from you, to hear if you like what you see. If you have any questions, really feel free to message us anytime. We want this to be very interactive, so so questions, remarks, anything you want to say, just say it. But as always, please remain respectful, because we are here to enjoy, we are here to learn and have a good time. So please be respectful of our speakers and also of each others in the comment section as well. So for the agenda, so we are just starting now. After this introduction, we're going to have our first speaker, Tiffany Souterre from Microsoft. She's going to speak about AI and TensorFlow. You see, she has done a really interesting project, and you're going to learn all about that soon. And then Ellie King is going to tell us some tips for your job search. So really feel free to watch the two talks, and stay at the end also, because we're going to have a raffle where you can get some tickets to Python Web Conf. And also, it's not written here, but we also have another conference where you can also get some tickets. I'm just going to mention it in 1 second. And just before that, I want to say the raffle, we're going to take the names at 8:25. But before that, we need to get a little bit ready. So we're going to share with you a form, and we ask you to please fill out the form by 8:10. So that means before the start of the last talk. That's so that we have time to really make sure that we take all of the participations. So for the raffle, I'm going to give you a few minutes, and also we're going to enter in the chat this URL. And this raffle is so that you can attend for free one of these two conferences. There is one called the Python Web Conf. It's going to be soon. It's going to be at the end of the month. It's an online conference on Python for web development. And then we have a conference which is PyCon DE. So it's the PyCon conference that is set in Germany, in Berlin. It's going to be a live conference that you can actually go to. And it's going to be in April. So when you fill out the form, please state if you want to attend the online conference or if you want to join in Berlin. And I guess that's it for the raffle. And I'm going to continue with a little mention about Ukraine if, Lisa, you want to present.
Hello, everyone. Good evening. As we all know, we are having a war in Ukraine right now, and I would like to know if any one of you would like to donate. Here is our URL that you can find our official place to donate. And yeah, let's help our friends that are also Pythonistas, which are in the situation right now. So thank you very much, and let's continue.
Yes. And we're going to present just very quickly the event that we're going to organize next.
Okay, so I will present it to you. We will have another event in April, in the very beginning of April, so just in a few weeks already. And this event is our first event, us means PyLadies Paris, which is on site with the talks post-COVID. So we are very excited, and we have two amazing speakers, Mojde and Guillaume, who will tell you about their work. And yeah, we are very, very excited about it. So if you would like to join us, please go to the meetup of PyLadies Paris and sign up, because we also have limited number of spaces only. So hope to see you there.
Yes. And without further ado, we're going to start with the first talk of today, presented by Tiffany Souterre. And I'm going to put Tiffany on screen. Up. Just bear with me for a second, and I'm going to share Tiffany's screen. Yes.
Awesome. Can you all hear me?
Yes, perfect.
Awesome. Thank you very much for the introduction, and thank you all for being here today. I wish you a very happy International Women's Day today. And without further ado, we're going to talk about what are adversarial examples. And first, I'm going to show you an extract of a movie that you might know. Maybe you don't have the sound of my computer, though. I'm not sure.
Do you want to try it? I'll let you know.
Yeah. Can you hear?
No. Can you do the voiceover?
No.
Oh, yes, please. I can hear you now. I can hear it, actually.
Okay.
Yeah.
Do not try and bend the spoon. That's impossible. Instead, only try to realize the truth.
What truth?
There is no spoon.
There is no spoon?
Then you'll see that it is not the spoon that bends, it is only yourself.
The Oracle will see you now.
So you might know the movie. It's The Matrix. If some of you have not seen the movie yet, I really encourage you to see it. Besides, the fourth one just came out this year. And for those of you who want to see it and don't want to be spoiled, I advise you to just mute your mic, and I'll do the sign for you to be able to unmute, to put the sound back, because I'm just going to spoil a little bit of the movie. So I let you mute. And for those of you who don't care about being spoiled or has already seen the movie, the Matrix one, so what the kid is saying to Neo is basically, there is no spoon. Why is he saying that? Because we live in this simulation called the Matrix, and it's not the real world. We all think it's the real world, but it's actually a simulation. And everything that we see, we feel, we touch is just information sent to our brain to make us feel like we are living those things, but it's actually not there. It's pretty much exactly the same thing with artificial intelligence. And so I'll do the same for people who can put their sound back. So yeah, it works pretty much the same for artificial intelligence and machine learning models. Basically, what they have is they have inputs, and they, through mathematical models, they will create an output and try to classify what they had as an input. And those inputs can be hacked, and we can fool a machine learning model into thinking that a certain input is something else and modify the output. So it's pretty scary because artificial intelligence is pretty much everywhere today. We trust artificial intelligence for our self-driving cars. We trust them for unlocking our devices, our phones, our computers. We trust them for security, for image recognition and videos and stuff like that. So it better be reliable. And we are going to see today how we can hack a neural network, and we're going to see also how we can prevent attacks against neural networks. So my name is Tiffany Souterre. Feel free to follow me on Twitter, or if you have any questions after the talk, don't hesitate to send me a message. I'll always answer. I'm a developer relation at Microsoft, and I'm also a Women Tech Maker ambassador. Without further ado, now, here you see a picture of a panda, and it's been classified by Google on it. So it's an image recognition model, and it's been recognized as being a panda with a confidence of 57.7%. And here we see almost exactly the same image, right? But this image has been classified as being a gibbon with a confidence of 99.3%. So what is the difference between those two images? The difference is just this. It's a noise that has been carefully crafted so that the model, Google Net, would misclassify this image as being a gibbon. And the noise has been multiplied by a very small scalar, so we almost can't see it with the naked eye, but it's enough perturbation in the image to fool the neural network into thinking that the panda is now a gibbon. So this has been published in 2016 by the team of Jan Goodfellow, who was working at Google Brain at the time. So other scientists tried this fooling neural networks into other images. So here we see in another publication that it works on pretty much any image you want. It works on a picture of a bus, a bird, a temple, speakers, a mantis, and a dog. So those are really different images. And basically what you see here is that all of the images on the left column are the original ones. And the noise that you see in the middle has been added to the image that is on the left column. And this is the resulting image. So we can barely see the difference of all of the pictures on the right column, but all of the pictures on the right column have now been classified as being ostriches. So, and this was by AlexNet. So this is another machine learning algorithm. So what this shows is that you can craft whatever noise you want to target a new classification for any image. So you might be thinking, all right, this works with images that you change on your computer, but does this translate into the physical world once you print the images? And this is what they show in this article. So here you see a library that has been printed on paper. And on the left, you see that the library is being recognized as being a library on the original image. I'm sorry. My internet connection is pretty bad. Yeah. And then the image on the right is an image where perturbation has been added to the image, and now the image is classified as being a prison. They did it also with a washing machine. And so the original image is on the left. Whoa. I'm sorry. Oh yeah, okay. Still my connection, I guess. Yeah, so the washing machine is classified as being washing machine on the right, and then on the left with the perturbation is classified as being something else. I didn't see what it was. And then we'll see with other examples that are a little bit more subtle, still with a washer. So here you barely see the differences between those images. The original one is on the left. So this one, and then small perturbation on this one, and a little bit more on this one. And you see here that the washer is classified as being a washer. And then as you move to the right, you see that it doesn't know if it's a washing machine or a switch. And then on the last one, it's definitely a switch. So these translate to physical world. Now scientists have been asking the question, well, can this be, is it possible then to hack face recognition apps? And so what they did is really interesting. Here you see on the top left of the image, the face of Reese Witherspoon, the actress. And they took this image and they added a noise in the shape of frames as if she was wearing glasses. And with this perturbation around her eyes, she's now being classified as being Russell Crowe, which does not look anything like her. But this perturbation is enough for the model to be fooled. So the next step that they did is that they 3D printed glasses with carefully crafted noise and tried 2 different types of attacks on machine learning models. The first attack is called impersonation, and the second one is called dodging attack. So here, column A, you see 2 people successfully doing a dodging attack, which means that they are now both unrecognized as being human faces by any machine learning models at the time. So now they can just go in front of a camera video and not being recognized as being humans, like the video won't see them. And here for the 6 other images, you see impersonating attack. So impersonation means that the people on the top row here are impersonating the people on the lower row, which basically means that this guy with those glasses impersonated Mila Jovovich and was now being recognized by this machine learning model as being Mila Jovovich. So if this guy can be Mila Jovovich, it means that if you know how to carefully craft 3D printed glasses, you can pretty much be anyone you want and be recognized by those machine learning models. But this was published in 2016, so it was a while ago. So now, as you know, we have advanced in our technology. So like now it's much more difficult to fool those neural networks, but at the time it was really scary. And now this is a really great example also that Anish did in this publication in 2018. They 3D printed a turtle, and this turtle was classified as being a rifle, so a lethal weapon. So if you go one step further into this thinking, it means that you could 3D print perturbations on weapons that would make them recognized as not being weapons anymore. So here is the first turtle that they're going to show is a control turtle. So it's a turtle that has no perturbation on it and has been recognized as being a turtle. If the video ever loads. Yeah, there you go. So with Google's Inception v3 model, the 3D printed turtle is recognized as being a turtle, no matter the angle. And then the second turtle is the turtle that has perturbation on the shell. You'll see you have little patterns around the shell, but it doesn't really change the shape, the overall shape of the turtle. But now it's been classified as being a rifle, no matter the angle. So, so those examples can be pretty scary, but don't worry. There are ways to prevent from those attacks. And to explain to you how we can first create those adversarial examples, I need to explain to you how a deep neural network actually works. So I'm going to take a very simple example in deep learning. Here is an image from the MNIST database. So it's a database of handwritten digits. And you can see that those images are black and white, so it makes the classification easier, just for the sake of explaining to you today. And they're only 28 by 28 pixels, so those are pretty small images. All the pixels in the image have a value, and this value just says where in the scale of black and white it lies. So if a pixel has a value of 0, then this pixel will be black. And if a pixel has a value of 1, then this pixel will be white, and everything in between is in the grayscale. Now I'm going to explain to you how deep neural network actually works. So we have first what we call an input layer. And the input layer makes up for all of the pixels in the image. So if you have an image that is 28 pixels by 28 pixels, you do 28 times 28, and it's 784. And that's the number of neurons you will have in your input layer. And the value for every single one of those neurons is the value of the pixel. So between 0 and 1, if it's black or white. And then you have what we call the output layer. And the output layer makes up for all of the different outputs that your model can give. So if your model has been trained to recognize handwritten digits, there's only 10 possible outcomes: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And in between, we have what we call hidden layers. And those neurons makes up for all of the mathematical complexity that we'll see together that will lead to the classification of the output. So what I didn't say is that in the output layer, what will make the classification possible for the machine learning model. So basically, if your machine learning model is able to classify that this image is a 9, then what it will show here is that it will show probabilities of classifications. And the probability that is the highest will be the classification that is predicted. So if the model is able to recognize the 9, then here the value will be closer to 1. And then all of the values here will be closer to 0. And all of the values added together will make up to 1. All right. So now I'll show you how to calculate the first value for the first neuron in the first hidden layer. And you'll see that this is the same calculation for all of the neurons in all the hidden layers. So to calculate the first value of the first neuron in the first hidden layer, first what you do is that you sum all of the values of the pixels in the input layer. To that, you multiply every single one of those values with a weights parameter, which has been calculated through training. And then you add at the end what we call a bias term. And the bias term will basically set a threshold beneath which the neuron should not fire. And then we have what we call a sigma function. So basically this huge sum here can be either less than 0 or higher than 1. And we want the value to stay between 0 and 1. So the function here, the sigma function, is what we call an activation function. And it will allow us to squish this number between 0 and 1. So basically what we do then is that we iterate the steps for all of the neurons and all of the hidden layers. And then what we have is just basically a matrix multiplication addition with the bias vector terms, squished everything between 0 and 1 with the sigma function, and this is what you get. So you don't need to remember all of the steps that I just showed you. The purpose of this slide is just to show you that deep learning is not magic black voodoo stuff. It's just basically linear algebra, and it's something that you can understand, and it's very explainable. It's just that there's so many calculations. It's such a huge functions that it's really hard to comprehend. But once you see that it's just linear algebra, that you see it's not that much of a, that much of a magical thing. Yeah, so basically this is what I just said. So you have this function, which is basically what the machine learning model is a function that takes an input of 784 values, and it will spit out a vector of values that will be your classifications here, your predictions for the output layer. Now that you know this, basically what a neural network is trying to do when it's doing classification is that it's trying to draw a decision boundary, as we call it, a decision boundary that will help the neural network to classify an image as being either a gibbon or a panda or a cat or a dog. So here, to visualize how it works, I'm only showing you one input layer and one output layer with only two parameters, X and Y. So that would mean that if it was a picture, it would be only 2 pixels. So a very small image. But if we want to visualize things, it's easier to visualize them in 2 dimensions rather than in 784 dimensions. So that's why I'm showing you this here. So imagine that this is your machine learning model. The decision boundary is right there. And the blue line basically makes up for all of the images of, let's say, dogs that you have. And the red line makes up for all of the images that are cat images, let's say. And once you train your model, the model will try to draw the best separation to separate this blue line with this red line. And as you see, it's not perfect. This straight line here has some images of dogs in the red area and some images of cats landing in the blue area. So those are being misclassified. But that's because we have only one hidden layer and one output layer. If you add hidden layers to this model, then you'll allow the decision boundary to have more dimensions. And now the decision boundary can curve. Now the separation between your dog dataset and your cat dataset is much more accurate. So that's the equation for the decision boundary, basically differentiating your dogs and your cats. And this image is very interesting because here you see that on the right, it's the exact same image than the one in the middle, but the decision boundary is now a straight line, and you apply a transformation to the space around it right here. So basically what the machine learning model is doing is trying to draw the best line, and it's applying transformation to your decision space to be able to remake for all of your samples and find the best way to separate your 2 data sets. If you have more complex data sets, let's say you have sparrows, so it could be, let's say, images of tigers and images of cats. So those are much more intertwined, and it's much more difficult to make a decision boundary between a tiger and a cat, for example. Then what the machine learning model will do once it's learning, it's applying transformation to the space to be able to draw a decision boundary that will make the decision possible. So, and this model is for 4 hidden layers. So that's still a pretty simple deep neural network. So it's not very deep, actually. But once you add more hidden layers, you're able to differentiate for much more complex shapes. Now that we see how machine learning models are trying to separate between different classifications, then I'll show you how you can actually make an adversarial example. And for this, well, at first, when I started to work on this project, I was thinking, what is the neural network that I want to fool? And I realized that at the time there was those machine learning models were pretty famous. We had AlexNet, GoogleNet, Inception v2, v3, v4, RASNet. And here I put in the middle the Andrzej Karpathy. So you can read his blog. It's very interesting. Basically, it's a human. And what this guy did is basically that he went through the same data sets that those machine learning models would go through in order to assess how well he would compete against them in classifying images. So that's the top 5 error rate that they were doing. The less you do, the better you are. And so basically, he went through a horrendous amount of images that he had to hand label, and he did them all. And his top 5 error rate was 5%. So this means that ResNet, Inception v3, and Inception v4 were performing better than he was at classifying those images. So I thought to myself, it'd be interesting to try to fool Inception v3, as this one was classified as performing better than apparently Andrzej Karpathy. And just for your information, this is the architecture of Inception v3 at the time. So it was trained on the ImageNet database, which has 1,000 different classes. So the output layer makes up for 1,000 different neurons. And it's formatted to have inputs that are 299 by 299 by 3. So that's the height and the height and the length of the image, and 3 is the depth for RGB for the colors. And as you can see here, for each squares that you see, you have a different hidden layer. So that's much more complex than just 4 or 3 or 5 hidden layers. You have a lot of different hidden layers here in this model. So for my code, I took a picture of my cat, and I wanted to make my cat classified by Inception v3 as being a spoon. So here is how I started the code. So you load your image, and then you resize it to 299 by 299. And then all of the values of your RGB depth of your image has to be squished between 0 and 1. And then just for the sake of checking, I asked Inception v3 what was the classification of this picture. And Inception v3 classified my cat as being a tabby with a confidence of 86% confidence. So that's tabby is a stray cat. So that's pretty much what my cat is. So that's good. And then what I did for trying to put perturbations into my image to make it classified as being a spoon, what you do is basically you take your image and your model. So here I showed you that the classification of my image, of the image of my cat being a tabby, is 0.87%. And then I checked what was the classification of the spoon for my cat. And the classification was, I wrote here 0.00, but it was actually 0.0 times 10 to the power something minus 16. So that was a very, very small number, although it was not equal to 0. And it was interesting because I was thinking, all right, so the classification of the tabby and the classification of the spoon, the classification of the spoon was really far from the classification of the cat. So I was thinking that's going to be interesting as a challenge. And basically then what I did is I took the gradient descent. And here, what is interesting is the while loop. So I put a while loop saying that as long as the spoon confidence is not as high as 0.98%, just 98%, so 0.98, then keep doing this. And this is pretty much take the gradient and take the learning rate and basically just change the values of the pixels in my image to get closer to the classification of the spoon. So what you need here to understand is that the gradient descent will give you the direction in space towards which you need to move your input. So here my picture, you need to move your picture to be able to go to the classification of the spoon. So I took the gradient descent for the classification of the spoon. And so this gave me the direction in space towards which I needed to go. And then I set the learning rate so that it wasn't too small. So the model wouldn't take forever to change my image to the classification of the spoon. But I wouldn't take also a learning rate that was too big, so I would not overshoot in the space of the spoon. So yeah, if I could just give you an image in the space, then it means that the classification of my image, the image of my cat lies here, around here, in the classification of the tabby, and then somewhere around here, there's the space of the classification of the spoon. And what I needed was to move every single values of the pixels in my image towards the classification of the spoon for my cat to be classified as being a spoon. And also, I clipped the change of the values in the pixels between minus 0.1 and plus 0.1 to make sure that the change in the image was not too big, so we would not be able to see it with the naked eye. Because if my image is completely changed, then people would see that the image has been hacked. This is the result I got. So on the left, you see the original image of my tabby being classified by Inception v3 as being a tabby with confidence of 86.86%. And then in the middle, you have the image of my cat that has been perturbed. And it's now being classified as a spoon with a confidence of 98.65% confidence. And I also did this with another classification, so the pineapple, with a confidence of 98.93% confidence. So that was, I was really excited. And at the same time, I was really surprised because I really did not see any difference with the naked eye. So I was thinking, is there actually any difference? So what I did is that I took a complete white image and then I applied the exact same algorithm to it to make it classified as being a pineapple. And this is the image I got. So as you can see, some little perturbations or some there and here. What I did with this image is that I took it, put it in GIMP, and then saturated the image to 100%. If you do this with a complete white image, all of the pixels will become gray. Here it's not gray, it's full of colors, which means that pretty much all of the pixels have been changed somehow. And now this has been classified as being a pineapple because the perturbation in the image is enough to somehow make the model think that now the image is not white anymore, it's something, it's a pineapple. But what it says also is that I don't recognize a pineapple in this hacked image. right? Maybe you see one. Tell me if ever you can see the patterns of a pineapple, but personally, I don't. And what this told me is at the time is that, well, probably that machine learning models don't have the concept of things. They do somehow mathematically see patterns in images to classify cats and dogs and glasses, but it's very much up to the math behind it. And so the concept of a cat and the concept of the pineapple does not really exist there. And so you might be thinking, all right, but I use image recognition in my apps, so there's adversarial examples. This adversarial example is what we call those fake images. And yes, you can through generative adversarial networks, which we call GANs. So I'm going to explain to you how you can create a GAN. First, you need your machine learning model, and you make a copy of it. And so the first copy will be what we call the discriminator, and the second copy will be what we call the generator. So at the beginning of the experience, those two copies are exactly the same. And what you do first is that you take a real image, here the real image of my cat, and you give it as an input to the discriminator. And the discriminator will classify this image as being a cat and will say, well, this image is real and it's the image of cat. And then you can reward the discriminator by saying, yes, you were right. This image is a real image of a cat. And then you go on with the second round. And the second round is the generator. And you make the generator generate a fake image. So here, let's say the fake image of my pineapple. And you give it to the discriminator. And you ask the discriminator, so what is this image? And the discriminator, because it's the same as the generator at the beginning, will think that this is a real image and this is the image of a pineapple. And you know that is not a real image because you just generated it, right? So now you can kind of punish the discriminator for not being able to discriminate between a real and a fake image. And you basically say to the discriminator, no, it's not a real image of pineapple, it's a fake image, and you should classify this as being a fake image. In the same time, you reward the generator for being able to fool the discriminator into thinking that this image was a real image of pineapple. And then you do this iteratively, thousands and thousands of times. What will happen over time is that the discriminator will be better at making the discriminator will be better at making the difference between real and fake images, but the generator will also be better at generating fake images. And here is an example on the MNIST database. You see here that those images have been generated by a generator. So you see sometimes it doesn't make sense. Like this image does not make sense. This image looks like a 9. This image looks like a 4. Some others don't make any sense. Like this image, I don't really know what it's doing. But it's actually able to recreate handwritten digits by humans. And so this has been published by the Goodfellow team in 2016. And basically what they were saying is that when you train your images on adversarial examples, then your model makes less and less errors over time to adversarial examples. While when you don't train on adversarial examples, your model will be always fooled by fake images. And in the same time, on clean examples, what we see here is that when you train your models on fake images, it's also being better at classifying real images. So that's a very take-home message here, is that it's always better to train on fake images and real images, of course, but to give also fake images, just because now you're training your model to recognize fake images, but also it makes your model better at classifying images overall. So this is the progression of GAN generation through time. So here you can see that from 2014 to 2018, we've made tremendous improvements in how we can generate faces. So none of those faces of people exist. They've all been generated by GANs. And you can see the progression has gone really wild. This was the state of the art in 2018, but already I cannot make the difference between the face of this woman and probably a real image, and that's really cool and also really creepy. If you want to try this, it's been created by Philip Wong, who worked at Uber. This website is called thispersondoesnotexist.com.
Sorry. Just to say that it's going to be time for Q&A. If you can.
Sorry. Okay.
But that's okay. Just we will start.
I'll wrap it up. Just just to show you. So you can go on this website, thispersondoesnotexist.com, and you can try it out. Every time you refresh the page, a new face is generated, and it's not the picture of someone. It's really a GAN that generated those images. It's a pretty cool website to go on. And I'll just finish there because sorry, I went over time.
No, it was really interesting. A really great presentation. Thank you. So we have a couple of questions from participants.
Yes, so thank you, Tiffany. It was really interesting talk. And we have indeed few questions.
Sure.
So I'll just gather the questions both from Munich and from Paris. So if there are any last minute questions, please do ask them now. The first question is, or the last, I will go from the end. What was the learning rate you set? I think it was when you showed the model when you did the pineapple and the cat.
The learning rate. Well, that's a good question. I went empirically, and I changed a lot of times my learning rate because the first time I tried this project, my model was running for like 8-10 hours straight, and it was not finding the while loop was going forever. So I tried a different sets of learning rate. I don't remember exactly the values because this code is pretty old, but wait. You can go on this GitHub repository, and all of my code is there. So that's the / there is no spoon.
Perhaps I could just ask Mo to share your screen once again, because I think you share.
Yeah, sorry. Maybe I don't know if I can send anything in the comment section. It doesn't seem like I can. Yeah, but so I created this repo for you guys to play with. So it's just to say before, it's pretty old. When I did this project, it was back in 2018. So of course, state of the art is not exactly like that. And today you have much better code to generate GANs. But you can play with learning rates. You can try different parameters to train on your computer, on your machine. So yeah, you can try it.
And one more question. It was more towards the beginning. You showed some coordinates, so some axes. The question was, could you explain what are the axes? Are they probabilities of X and class and Y class? Yes, I think it was really into the beginning.
So
decision boundary.
Right there. Was it about this?
I think it was before, but I will ask the Srihari to correct me.
Yes, they said yes, that's it.
Okay, So no, this is a very simplified way of representing data in the space. So this is not probabilities. Well, you can go on the blog of Chris Olah, which makes an extensive explanation of this graph. But basically, every single dot in the line is a sample. And so it would be more represented not by a probability, but more by a position in the space. So basically just exactly where a sample has this coordinate in the space. So as I said, for an image, it would be only 2 pixels, which is not a normal image. But this space should be much bigger as your input layer is bigger also.
So thanks for your answer. For the sake of time, I will not ask you any more questions, but perhaps you could stay with us a little bit longer, and if there are any questions, still you can ask them on YouTube, and Tiffany will hopefully answer them. Thanks a lot, Tiffany.
Thank you.
So yes, now we have another speaker, which is Ellie King. If you are looking for a job, normally in the job search, it's difficult. You have to organize your CV, your LinkedIn, you have to present yourself, and especially in tech, with a very competitive area. And Ellie, she will bring some light for us on this topic and help you maybe there. You're looking for a job. That's it. I will give time for Ellie.
Hello, everyone. Firstly, happy International Women's Day, and thank you so much to the PyLadies community for welcoming me. I'm so excited to share with you some of my tips for job search and really hope they can be of value. I just want to shout out my co-founder, Jonathan, who is into Python coding, who did this small piece of Python code for me on the first slide. So let's jump into things. My name's Ellie King, and I'm the co-founder of Equal IT. And we're a mission-driven business, really working to diversify tech teams for refined talent acquisition. And we complement this with diversity and inclusion consulting. I've been working in the tech recruitment space for around 9 years now, and are just really passionate about all things diversity, equity, and inclusion. And I'm also the host of the Equal Inspired podcast. A fun fact about me is that I am a huge Harry Potter and Disney nerd. You may see on my shelf in the background that I've got a few memorabilia. So let's jump into it. Your job search. Now, before we do absolutely anything, it's all about understanding your why. I'm a big fan of Simon Sinek, and he does a presentation on Start With Why. And it's a great chance for you to really gain clarity and to reflect on yourself, to create a better CV, to help you in your job search and interviews and more. So it's understanding your why and taking the time to self-reflect. So firstly, I recommend blocking out around 30 minutes to an hour, take a pen and paper, and I want you to really think long and hard and to write down your strengths. When I say that, this is from a technical and a soft skills perspective. So think of things like communication, team spirit, ambition. Write down tangible examples or scenarios that really back up your strengths. What is it you've specifically done? What direct value and impact has this had on your business, on your team? So take a think about that. Next is the growth phase. Now, what I mean by this is areas to improve. So what do you want to learn and achieve moving forwards? And really dig deeper to understand, why do you want to learn this? So how will it benefit your career? How can that then add business to a potential new organization that you want to join? And are you already being proactive in improving in this area? If you are, can you share, again, a tangible example? Are you making a certification, a course? If you're not, how can you start? And also think about maybe the reasons why you haven't already. Next, it's thinking about your values. Now, these are your absolute non-negotiables when it comes to a new business and how they align to your own. Super, super important that you're aware of the things that you value the most. And then it's really diving into fulfillment. What do you really enjoy? And what gives you that fulfillment in your career? So when I say that, I mean, it's really about remembering your why. Sometimes in our careers, we can get caught up and lost in the process of achieving goals and whatnot. So it's going back and writing down your motivations for working in technology. Think about who or what inspired you to start. And at this moment in time, what really makes you most happy and why? And also think about what you dislike and why, and write that down. Now, taking all of this into consideration, all of these different bubbles, the final thing to do is to ask. Now, when I say this, it's speaking to friends, family, colleagues, and actually asking them what their perception of each bubble is of you. So getting some feedback from them. And what this really does is it enables you to cultivate a very strong list of factual evidence of your abilities, of your capabilities, and it puts you in a fantastic position moving forwards to have clarity for your CV, for cover letters, for job interviews, and beyond. So we are now in a very crowded job market. So now more than ever, it's so important to stand out from the crowd. And you can do this by really taking control of your personal brand. And this is going to help you so much in your job search, in your career, for your personal development. Working on your personal brand really does attract so much opportunity, whether that being you being approached for jobs or a mentorship scheme, anything. It really enables you to build trust and to gain focus as well as an individual. It allows you to become a real expert in your field and to ensure that you're always being aligned to your values. And more importantly, you build confidence. You really will flourish if you're working on your personal brand. It will keep you energized. You'll be achieving goals. It can really help to fight things like the imposter syndrome as well. And of course, it helps you to enrich your network, which is so important. Your network is your most valuable asset when it comes to your job search, which in turn, again, attracts potential opportunities for you. So working on your personal brand, it requires some commitment. The first thing is consistency. Now, it's to really be relentless, find your flow and keeping at it. I recommend booking out initially maybe an hour a week to work on things just for your personal brand, and then to slowly work your way, build it up and become more frequent and comfortable working on this, but always having your personal brand in mind. Next, it's going to require you to be really authentic, so very true to yourself, always taking the time to self-reflect and really taking a long, hard look in the mirror and being able to challenge yourself, challenge your ideas to see how you can improve and always be better. It's going to take confidence. It really is coming out of the comfort zone, putting yourself out there, having that belief in yourself. But this is why that first exercise is so important, because it just keeps reinforcing your abilities, your strengths, and what you're great at. And it's going to take resilience, just like with a job search. It's having the long game in mind with your personal brand, knowing that you may not have wins straight away and overnight, but if you keep doing the great things, you'll become recognized and you'll open up so much opportunity for yourself. So I just want to share a few ways with you in how you can work on your personal brand. The list is endless, but just for time purposes, I'll go through two. Now, the first is building an online presence, creating content. It's about finding your voice and being consistent. Now, for so many, I completely understand this really is coming out of the comfort zone. So maybe you can start small by just engaging on LinkedIn posts, on tech Twitter, making comments, and slowly build your way up. But I really recommend looking to create like video or blog series. Think about, are you learning something new? Can you document this, for example, in a series? Or are you attending a course, a boot camp? Have you been to a meetup or an event? Can you review your experience and your summary and your biggest lessons learned and your challenges and hurdles? Have you worked on a recent project? Again, can you share the project, what it entailed, your lessons learned, your knowledge and your achievements? Just always think about how you can add value to people. Even from simply sharing your journey into tech can really help one person and be so valuable. Sharing advice on topics that you're passionate about, it really is just, again, coming out of your comfort zone. It can seem a little bit daunting putting yourself out there, but if you're talking about something you genuinely care about, I can tell you now, you cannot go wrong. So like I say, you can also post on LinkedIn, share about different events that are up and coming, just to start building a little bit more of a presence and engaging conversations, but have the long game in mind as well. Do it for the right reasons, be true to your authentic self, and just having your mindset that if you can help one person with the content that you're putting out, then you're doing your job and the rest will follow. You really will start reaping the rewards. Companies will really be excited about this because it showcases your confidence, the fact you care about sharing your knowledge, and it enables you to build a fantastic portfolio outside of just your CV and cover letter that you can share with organizations that's really going to help you stand out. Secondly, look into volunteering. It really shows that you value the community. Not only are you going to gain hands-on experience and be making a direct impact on the lives of so many, but to organizations, again, it highlights your commitment to your own values, that you want to support, you want to inspire others, and you're willing to invest your own time to do that. Some companies also support many communities, nonprofits, different initiatives. So it's a chance for you to build relationships and network internally. Potentially that could open up so many job opportunities and possibilities for you. So you'll also be learning so much along the way by being involved in volunteering, but you'll open up so much possibility for you. And again, it's something that organizations would really value. So we've worked a little bit on our personal brand and how we can stand out. Let's talk about cover letter. Some companies do still require this, some not so much, but it's important just to keep these things in mind. So the reality of a CTO is that they receive hundreds of applications and recruitment is only a small percentage of their day. So at times they can quite literally only invest 30 seconds reading a cover letter. So it's really important for you to understand that you only have a few seconds to connect and to capture their attention. So with this in mind, let's look at your cover letter as an elevator pitch. Now, when I say that, let's use Google, for example. You're going into Google's office, you're on the first floor, you're stepping into the elevator. The hiring manager for the job you want at Google goes into the elevator with you. You have from the ground floor until the top floor to tell them how you can add value to their business and the position and why they should hire you. And that's how you need to think about your cover letter. So less is really more in your cover letter and making it very punchy. It should be something to complement your CV as well. So it shouldn't be copying and pasting anything directly from your CV. This is a chance for you to really show your personality, your characteristics, to tell a story and to constantly make it clear how you can add value directly to the position and the company that you're applying to. So there's a common theme throughout what we're going to talk about. It's all about tailoring and customizing. So this is what you should give thought to on your cover letter. Diving into your CV, here are just some of my tips. Now, again, from your cover letter to your CV, it's so important to tailor and customize. It should be a real honest reflection of yourself and your skills and just be really personable. You know, you're not a robot, so don't fear being creative a little bit to stand out, maybe throwing in a quote on your CV that you really live by and you value, and always think value. Try to avoid buzzwords and overused phrases. Really, if you're going to list things like that, like team player, ambitious, can you back that up to demonstrate how you are? So making sure that your CV is really evidence-based. And then just the typical things I would say, make sure that there's consistent formatting, be sure to proofread, subheadings, bullets, and try and limit it to 2 pages. Now, on the CV, what I would expect to see is a personal profile or an about you. This should really provide an overview of who you are, and it's outside of your cover letter. Again, these two should complement one another. So it's, for me, understanding how you can add value to this position and the organization, understanding about your why you specifically want to work for the organization. And with that, it would be showing you've done some research maybe into our culture, into what it is specifically we're working on, into funding that we've just received. And it's listing maybe top 3 soft skills, but backing that up again with tangible examples. If you're ambitious, driven, how can you prove that? Can you put something, get like a percentage, the direct value that your work has had to prove this? So I really recommend having 4 or 5 bullet points to highlight each area and just making it, again, really powerful, punchy, linking it specifically to that business, to that job description, and really relate back to the exercise we did at the beginning. All of this information is going to be so valuable for you to create something so powerful and factual and, again, tangible. So diving into the employment history section of your CV, now I really want to stress to avoid being generic. Go beyond just listing your job description. So explain a problem that you've addressed, the action that you took, and the results, the value, and the impact that this created. For example, this enabled us to deliver 5% improvement on XYZ project. Really tell a story. List maybe the top 3 things that you feel you've learned from your experience so far in the business. And again, that's showing an organization you can self-reflect, you can analyze, you're self-aware, and really use metrics and value. Like I said, this should be a common theme throughout your CV, your cover letter, and using action verbs. So things like organized, engaged, influence, these are going to be really vital for your CV. So outside of your relevant technology skills listed, of course, your education as well, a few other layers on your CV, I just want to share what we would specifically look for from like a tech recruiter perspective. So for me personally, it's hobby projects. Are you active on GitHub, Stack Overflow? Are you really passionate about what you do outside of just your job? It's community. So that to me shows you really, again, care about giving back. And these skills are so transferable to a potential business, and these kind of values and this mindset. Really, for me, it's about being able to understand your why as well. So listing the values and really seeing that you genuinely care about what you do. I always want to be seeing tangible examples. This is how you're going to stand out from so many CVs that we see, by backing it up with metrics and percentages. If you can throw in any characteristics and show some personality, that's always great. And I want to be seeing that you're passionate about learning and that you're being proactive in doing that. So please put on certifications, boot camps, anything you're doing that's enhancing your personal development. And also things like your personal brand, like we discussed earlier. What are you doing to stand out outside of just your CV and cover letter? So let's talk a bit about the job application. It can be quite tiresome, quite daunting, quite exhausting actually for so many. And I've been having a lot of conversations with people who have been sending their CV to so many businesses and not hearing anything back. So you're certainly not alone in these challenges. Here's some tips that will help you to minimize that rejection. First of all, again, I can't stress it enough. It's tailoring and customizing. You are not a job application robot. So really take the time before you even send your CV and cover letter to analyze the business. Analyze the pain points of the role that you're going to be applying to. What are the company's values? What's really important to them? And reflect. How can you add value to that? Again, provide tangible examples and link back to that self-reflection exercise. It can be quite time consuming, don't get me wrong, but it's so worth it in the long run. These smallest of things can really make the biggest of difference. Just having the mindset of short-term pain, long-term gain. That's what I always say. And can you mirror any language that's on all of the company's website and literature and the job description? Can you mirror that into your CV if you feel it's aligned? Before you send any application, get a review and ask for feedback from friends, family, anybody that you trust. This is so important because first impressions matter. Next, it's diversification. So it's giving yourself a variety of different options, which enables you to gain so much more feedback on your CV, potentially from organizations. It allows you to practice and interview scenarios as well. So it's just about having some backup plans. Yes, have your top 3 businesses that you want to work for and you're really passionate about, but just being mindful of that. Next, it's networking. This will really help you stand out. So can you connect with people in the potential organization you want to work for and openly speak with them? Just get to know them and find out about what they enjoy about working in the business, the challenges that they're facing, how they're overcoming this, and just share ideas and inspiration. Add value to them and you'll receive some information from them. And ask for an internal referral potentially, because some companies give bonuses to their staff for referring potential new hires, and just get to know them and use this information to help you formulate a stronger application for your sending your CV or for the job interview process. That's going to be really impressive to show to a business you've done your research, that extra research. Is a potential company you want to work for hosting any events? Can you attend there? Can you go there and get speaking to people and show face and show your interest in positions and actually have that face time? And if you go to an event that you really enjoyed, why don't you mention that on your CV or your cover letter specifically to that business? Just be really proactive, come out of your comfort zone. And again, when it comes to the networking aspect, I recommend maybe booking 30 minutes every other day to focus on networking. So you're always doing it and you're being quite meticulous with it, because it's so important and it's going to make such a difference. And finally, it's just about being resilient. It doesn't happen overnight in some cases, but keep going, keep being positive, keep doing all of these things, and you really will get there. Look at every experience as a lesson learned and use any failure to fuel your motivation to do better. Now, my Harry Potter nerd is coming out right now, but let's look at J.K. Rowling, for example. She pitched Harry Potter 12 times and it was rejected 12 times. And now look at how successful Harry Potter is. So just be really resilient and keep going and you'll get there. Thank you so much, everybody, for listening. I really hope these tips have been of value. To celebrate International Women's Day and for everybody in the PyLadies community, I'd love to offer a free one-to-one session to dive deeper into any of these topics, to give you feedback on your CV, to share any advice that you may have. So please feel free to book in via email or reach out to me on social platforms. And I hope you all have a lovely evening. Thank you so much.
Thank you so much for the talk. I think it was amazing. I see some commenters, people are really happy about it. See here, nobody had a question, so everything was super clear. But some people really are happy about it, the event. And there is one question here. How do you suggest one should start networking and how someone can be good at it? It's from Tapitcha. Yeah, you can answer, please.
Yeah, that's a great question. So I would recommend starting small. So take advantage of social networks and social platforms. So if you're on Twitter, can you start maybe engaging in people's tweets around Python or technologies that you're excited about and just start kind of building that traction? Can you connect with people on LinkedIn that inspire you or who are working in similar areas as you, working with similar technology? And just be really quite open and say, hey, I love this technology. I can see you're working with it. Your background in XYZ really excites me. I'd love to share ideas and inspiration, and just build up slowly from that way. And then you can start to maybe take it to the next step and book like virtual coffee meetings and things like that. I would say it just takes practice. There's no right or wrong, but it's all about just putting yourself out there. And don't get me wrong, it probably every single reach out that you do, you might not get a response, but that's okay. The more you do it, the better you become. So just don't give up if you don't have any traction initially. You will in the long run. And like I say, just be genuine, be humble with your approach.
And don't take personal. You never know, like sometimes you're contacting people and they are very busy or they don't see the message. But I also, I have this, I always contact people there because they are so reachable. Now everyone, you can just find them on Twitter, you can find the email, you can find them on LinkedIn. So take advantage. So thank you so much, Ellie. That's it. We're gonna go now from the Raffle. Thank you a lot. And as she say, we passed it here if you want a free consultation, if you're looking for a job and so on. I think you should take advantage of this valuable opportunity. I think it's amazing, really. Thank you so much.
Thanks.
So here we are ready, preparing for the Raffle, right? So everyone here is very excited and waiting for this moment. So we're gonna start it. We have already stopped it, so you cannot fill the form anymore. And we're gonna start it with one of the Raffles. Who you think will win?
Good question.
Yes.
We have 2 winners today. How many winners do we have in total, Laisa?
So today we have 4 prizes that we're gonna share with about 9 to 10 people. So I think almost everyone will get out of a prize. So it's great. I have it here, this Python script. Of course, we have to use Python for Raffle. And we have here all contestants and the prize. So the first thing we're gonna raffle is the Python Web Conference ticket, and we're gonna run now. Are you ready?
Yeah, ready.
I need some emotion. So let's run. So the first winner is Nuria. If you are there, say hi in the comments. And the second winner is Susan. Congratulations. I don't know if they are there. Maybe they are here. If they are from PyLadies Munich or PyLadies Paris, but congratulations. One moment. I will change the screen before we go to the second round.
Yes. Hey, so we have Nuria said hi in the chat.
So this is actually even more exciting, the second one, because we have 3 people who wants to go in person for the PyCon DE, and we have 2 tickets. So we have 33% chances that you can win in this one. So pretty lucky people. So we're gonna run now. Let's see. Congratulations, Octavia. You have won. And congratulations, Prapti. You also have won. I really hope you can attend to this in person. Woohoo! She was all the time talking. So you will win. So we see each other in Berlin next month. This is amazing. Wow, such a winners. Are you happy, people? Let's say congratulations.
Yay, congratulations to the winners.
I will paste the results for us, but I think everyone who has win is already aware, but I will paste the results here. And yeah, if you have won the prize, contact us from the email address from PyLadies Munich. I will also display here. And you also left your information, so yes, so please email, not for the book, but for the prices, because we're always giving something. But please email us, and we're gonna make sure that you receive the prize. So it's here, the email. Can you see it?
We can send a comment in the chat with the email.
Awesome. So did you want to share something else? Is there more news that we want to share about the next event, right? Yeah, so here's the email. Just go there and write us. We already know who are the winners, so we're very happy that you won. Yeah. Do you want to say something? Has final words, Maud or Maria?
Yes. So let me just share my screen again. Can you tell me if you can see my screen?
Yes, we can see it.
Okay, so we have done the raffle, and we just had a last word just to remind you that we have a next event coming up. It's going to be a meetup on the PyLadies Paris meetup.com page. You can find it. It's a meetup in Paris, so it's mostly for people who are already in France, but if you want to take a trip to France, it's also great. We'd be happy to have you. And so it's going to be in April, on the 5th of April in the evening, so same time as usual, with the two speakers, Moshde and Guillaume from Saint-Gobain and Scikit-Learn Foundation. And thank you. That's it for me.
Thanks a lot. It was really great being here with you tonight. I hope to see you again soon.
Yes.
Yes,
Thank
thanks
you.
everybody. And it was great to do this meetup with you. You too. And thanks everybody. Have a good evening and happy International Women's Day.
Thank you. Bye-bye.